All right. So I should probably start out by saying that I haven't really done anything like this before, but um, I actually got inspired by a podcast called Systems Live a little bit, which is about two guys talking about systems and distributed systems and programming and all that.
Cool.
And I thought, well, because I'm such a fan of like the NSQ code and some of the code that you've written, I thought I want to interview this guy and just talk about code and style and patterns and stuff like that. Especially because I'm pretty interested in the diskqueue code of NSQ and now the new write-ahead log that you're working on.
Sounds good to me. I'm excited.
Yeah, cool.
Thank you for setting this up.
Cool. So I guess maybe we should probably start by having you introduce yourself and just say what's your background, programming-wise or whatever. What are you up to?
I got started, kind of one of those self-taught situations, playing with computers at an early age. My first language was my first real language was C, actually. I built a lot of games in DOS back in the mid-90s. When I got to the point where I could actually work professionally, then it was more like, the advent of, the web was exploding, and, that was like probably my PHP days in the late 90s, early 2000s.
PHP, you said?
Yeah.
Yeah, I think we all had our PHP days, right?
Yeah, I had some like startups in in and around finance in those days, in like the New York area. Did some consulting for a long time. Still mostly doing just web services and backends, but that's where I got my first real experience with managing larger sets of data. Like financial market data, things like that. And I think a lot of that experience paid off. And then eventually sort of meandered a bit, made my way to Bitly, and was part of the systems engineering team there, and we were responsible for all of the infrastructure and platform that that Bitly ran on. So that's when we really was able to dig in on the lower level distributed system side, and NSQ came out of that. So that's like a real short description of the last 17 years of my life, I guess.
By the way, it sounds good for you? For me, it is, for what it's worth.
Yeah. So, I mean, at Bitly, that's where we started. The stack was originally Python and C, and we had a bunch of, small utilities that are also open source for what it's worth, but didn't quite, get the build a community like NSQ eventually did. Go was a language that we were really interested in early on, like pre 1.0, and we started experimenting with Go as like a tool for internal use at Bitly. And roughly around the same time, we were interested in rebuilding some of the messaging infrastructure at Bitly. So those two sort of events coincided to provide sort of an opportunity for us to both learn the language, learn it while building, a critical piece of infrastructure for Bitly, and both at the same time. However, I think it created a situation where some of the first NSQ code is not the greatest or most idiomatic Go, which is I think we've slowly cleaned it out over the years, but there's still some lingering in the back corners,
Yeah. Yeah, and I remember, we met up at one point in New York, you and Jahaya and myself, to chat about that. And I'm still, to this day, I'm just going to repeat what I said then. Like, it's a really nice project, and it's almost surprising that it was your first Go project. But I guess now I can see, if you've been like a C programmer, how maybe that has something to do with it. Because if you're good at C, then it shouldn't be too hard to adopt a language like Go, I guess.
Yeah, I think it felt very natural for us to move from Python and C to Go. it's not a tremendously different paradigm in terms of the way you're programming in Go. I think we were definitely interested in, obviously, the concurrency primitives that it provided. A lot of our systems handle many requests often at the same time, so that was a motivating factor. And we were sort of sick of writing. I mean, I love C. I've always loved programming in it, but I also recognize that it's it's a language where you can shoot your foot off. So wanted a little bit more safety, and we thought the things that we were building in C could easily be built in Go, probably become more robust, but also more just like more concurrent too, obviously. The things we were building in C were all based on libevent, like interacting directly with the libevent library. So they were, IO loop based, but they were still essentially single threaded. So, that coupled sort of manual memory management, we had some nasty bugs in some of those daemons that it just didn't seem like it was worth investing in fixing them, rather than sort of investing in a language that we could grow with a little bit more gracefully.
Yeah. And so it is a quite big project to take on, I guess. Or like, did you see in advance, like, okay, holy shit, we're gonna build like a whole queuing system here from scratch in a language that we haven't really much experience with?
Yeah,
how did that feel like?
Reflecting back on it, it's probably crazy. It sounds crazy.
Yeah.
Those are sometimes the things that pay off the best, maybe, is the one way of looking at it. The marketplace at the time, we're talking about like 2011-ish, you had, RabbitMQ was a clear like market leader in terms of this type of stuff, right? Like there were a lot of, companies we respected that were using it. It probably could have satisfied the needs that we had, but we had concerns about, we were at Bitly, we were very sort of conscious of the dependencies we chose, whether those were, the modules or packages we compiled into our apps, or the other systems that we built our infrastructure on. So, we had a large production infrastructure that was already operating at scale that needed to continue doing so as we migrated to whatever new messaging platform we would have chosen or built, right? So we had very specific requirements as to the way we wanted the interface to the rest of the infrastructure to be. And because of that, we knew that whatever we would have chosen, whether it was Rabbit, whether it was Kafka, whether it was something more homegrown on top of ZeroMQ. By the way, like Kafka at the time, wasn't, I don't know, like obviously it's become a extremely stable, robust platform, but at the time, it didn't quite have the adoption that it obviously has now. And there was a question around inheriting the Zookeeper dependency that sort of comes along with it, right?
Right, yeah.
It's sort of really against, like we like the idea of Kafka, and NSQ obviously shares some design principles that are similar to Kafka. But we didn't like the fact that we also had to then maintain and administrate, a Zookeeper cluster. But anyway, getting back to what I was saying, is like the interface that we needed to replace the components that we had in production was very specific, right? We needed to be HTTP on the input side, and we had like a bunch of things that we wanted the interaction between a consumer and the cluster itself in terms of behavior, like back off and like retries and all those kinds of things were important to the way that the whole system worked, and we needed to replicate a lot of that. So like, let's say we would have adopted Rabbit, I don't think we would have had to have built all of these shims in between our infrastructure and the way Rabbit expected things to work, which I think, we thought like I think our opinion was like, it's just a queue, right? So if it's just a queue, and we know we need to build these interface related shims anyway, why don't we just see how far we can get just building the whole thing, right?
Yeah. Did you have like any particular inspirations, like other projects that you saw the code of that you thought, because you mentioned, your C background and your Python background, but then, so you obviously have an experience in like systems programming or,
Yeah.
but then you need to adopt like these new paradigms or these best practices for Go. Did you see any projects that were like inspiring to you and how to organize code or how to tackle problems?
I mean, on the Go side, or you mean more just like other message queues that we were inspired by?
I meant Go, but actually both sounds interesting.
Well, I mean, on the Go side, you're talking, we started building NSQ before Go 1.0 came out. The repository doesn't reflect that. However, it was already like an internal code base before we open sourced it. So like whatever the first commit is on the repository, it's probably 6 months of development before that, I would say, off the top of my head, which I think predates Go 1.0. So the answer is no. Like, I guess the best project that I could name would be Doozer, which was a very early Go code base.
Right.
The project has sort of languished and fallen by the wayside and replaced by things like etcd and console. But back then it was probably the largest community-based Go project that existed. I think NSQ quickly became right up there, especially in the early days. Like, there weren't that many projects that had the visibility that those projects did at the time, like Go 1.0. So it was really trial by fire. We would try certain approaches. We would experiment with, certain aspects of the language, whether it was Go routines or channels. A great example is like early on, the first iteration of NSQ, message timeouts and like defer timeouts were all managed with a Go routine per message. So each message had like a Go routine that was running with a timer that when the timer expired, the Go routine would requeue the message essentially. And obviously that meant that like when you had hundreds of thousands of Go routines, messages in flight, that you could potentially have hundreds of thousands of Go routines waiting for timeouts. And, their documentation and their, the way that they talk about Go always states that Go routines are, you could spin up that many conceivably. However, they're cheap. They're not free, right? So there were two problems. There was like the memory related issues with launching that many Go routines, and also the lack of back pressure internally. So like it ended up being a terrible implementation for some of those things. And we've since moved to like either Go routines per channel to manage in-flight queues with the priority queues,
right,
or a single top level. We now have only one Go routine per NSQD. So
only one single Go routine per NSQ?
For managing in-flight timeout.
Right.
It's essentially like a garbage collection process that runs.
Right.
It scans the topics and the channels that are running, and if there's any work to do, it sort of does that, and then it measures. It's actually basically a copy of the way Redis expires keys. So if it did more, let's say if it scanned 10 channels and 4 of them had work to do, and that was above the threshold, like 40% of the channels, then it would continue to do another iteration immediately until it was under, 20% or something. I don't know what the defaults are anymore. But
right.
So I mean that sort of simplifies, one, the number of timers you have running, which is still one of the things you need to be careful of within the Go runtime, and two, just managing your Go routines, just bounding them and knowing how many there are in relation to the work that you're doing in the process, I think is still something that's critical for like a robust Go application. So it was something we learned the hard way. There was really no way to
also pragmatically, if there's ever a panic, like every single Go routine adds kind of noise, and I haven't really found a way to like nicely. I mean, I just jump when I have a panic. I just jump to the one routine that says running, and then usually the problem is there. But
right.
I don't know.
Yeah, it obviously complicates debugging as well. I mean, like there's some great techniques you could do. Like you could treat Go routines like pools, and then feed work to them via channels and things like that. So we do that too. But yeah, like early on, those lessons were all like hard earned through experimentation.
Yeah, it's this. There's one particular pattern, I guess, that I really liked when I found it, and I think I found it first in statsdaemon, and then I saw it again in NSQD. And you mentioned earlier IO loops, and actually the function in NSQ's diskqueue is literally called IO loop, but it's basically this way, or the way I would explain it, if I would have to explain it to someone, is okay. You have all this data that you need to protect, and you have all these different functionality that somehow changes that data. And then you have like, and the way you solve that is the select with like 5 or so clauses.
Right.
And that reminded me a lot of an IO loop in something like C or in Python, even though I'm not sure if it's the same, but to me it looks a lot like it. Is that how you think of it as well?
Yeah, I think, the diskqueue is another example of where I think we got it wrong in terms of its first implementation. I think the first time I wrote diskqueue, if I look back at the code, I tried to take an approach of very fine-grained critical sections with mutexes and approaches like that, like really fine-grained locking. It had deadlocks, it had race conditions, it just didn't work, right? And when I finally got it to the point where it did pass tests and function well, like I think a couple versions that were released of NSQ had that approach. One would argue or maybe expect that moving to that single IO loop, which essentially all it does is synchronization, right? Like that IO loop, that loop of that Go routine can only really do one thing at a time, right? Depending on what channel wins in the select, that's the operation it's going to perform, and then it's going to continue and repeat again, and then perhaps some other operation is available to do something. But essentially, all it's doing is synchronizing. It's serializing those operations that are coming in to guarantee you're only operating on, like either you're only doing a read or a write at any given time, right? That's specifically what it's doing for the diskqueue. But I think my first, I believe that would have been a slower approach in terms of performance when I first wrote the diskqueue code, and the reason why I went with fine-grained locking. However, I think when I ended up benchmarking things, it proved to be actually more performant to do that.
To do the single select like it is now?
To do the single select rather than the locking approach that I had gone with. I haven't actually gone back to really evaluate why. This could just be an example of the first version of the code that I wrote was bad for other reasons, or the locking had some contention that it obviously was contributing to some performance issues. But the point being that, like, simplifying the code often with Go and trying to do things with the tools and the primitives that it provides, at least starting there as a baseline for correctness, you can provide like a more stable foundation to then increase performance. And I think it has all these different types of tools depending on the problem that you're solving, right? Like sometimes Go routines and channels are appropriate. Sometimes that single select loop that's operating on many different channels that are all providing asynchronous operations is a useful approach. And then sometimes, obviously, if you're just protecting concurrent access to a map or something, locks are probably the most efficient and clear to read, right? Like oftentimes it becomes a question of readability. So, if your code is readable and then it ends up being as performant as you need it to be, then I think that's the best case, right?
But so you mentioned, okay, so you had very fine-grained locking, and then you switched to a not very fine-grained select because it's a single select. But aren't those two kind of orthogonal in the sense that you could have fine-grained locking as well as coarse-grained locking, like basically having a single global lock or a few global locks, in the same way that you could also potentially have two different select loops running in different channels, protecting different data, and in that way it could also be more fine-grained and still be selects. I wonder if that would perform any better, but it's just a thought.
Yeah, I mean, I think I think it's really about I go back to the readability point. I think there's clarity in the way that the diskqueue code is currently written, because you understand that these are the things that it doesn't try to do in parallel, right? And yeah, like I think you and I have even had a conversation about this in chat, that like I'm sure there's opportunities to make it faster, you know?
Right. Yeah.
It's not something that we definitely spend time thinking about the code that we're writing in terms of performance, but it's not always the most important goal for us.
Yeah, and you're usually bound by network speed or disk speed anyway, right?
Right. Yeah, I think, yes, in that case, yeah, I think, you know, with writing to disk, for example, I think it's all really about, you know, batching, really. I think that would be the most useful improvement there, is like performing more writes before you flush, right? Trying to pack those in.
Yeah.
So, you know, you can ingest as much data as once, and I don't think it does a great job of doing that right now.
So one thing that I also wanted to mention about this IO loop thing is that a lot of the operations within the IO loop are actually exposed through like a public method, which I thought was really interesting and makes me wonder, you know, you kind of want to expose this, or you kind of want to implement this channel-based API or this channel-based synchronization with the select, but at the same time, it looks like you want to expose a function API, but then that function actually just puts something on the channel and then reads something from a different channel. I thought it was interesting.
I think, you know, my philosophy around like API design inside Go, I think has settled on, if you can avoid it, channels should not be in your public API, you know? So I think exposing those contracts as functions, right, with strongly typed parameters and things like that, and it's really using whether it's channels or, you know, something else, or spawning Go routines and whatnot, I think you should leave that to like either the caller to make it asynchronous. Like if they want to background something, essentially, they would call it in a Go routine. So don't necessarily force concurrency on somebody. And also, you know, don't expose channels directly to the end user, because most often they don't necessarily want to interact with that. You know, it's sometimes more complicated to interact with them that way, basically. There's a great post about, you know, channel design and APIs. I think I forget who wrote it.
Yeah, and what was that, the post where they talk about should it be the caller or the callee who gives the channel to the other, and should it be buffered or not, and how to document what is the behavior if you block and that stuff.
Like it. Yeah, I know that there's been some good writings on this within the last, you know, year 18 months or so. I feel like, but yeah, when I'm designing public APIs for stuff, I usually hide some of those details.
Yeah. So also when I was thinking about this approach of the channels and the selects versus like a more pure function-based API, where maybe like not just an API, but like a function-based implementation where you use logs. One thing I realized is, or that I hit in another project, is that if you have a chain of like multiple functions calling each other because you have like different levels of abstraction, whenever you use channel, like you always have at least one thing in flight. And I don't really know how to explain it. I haven't really thought about it a lot, but it feels like if you have a function calling another function and then the values are being passed as return values, it's like you can guarantee more some kind of synchronization. Whereas if you read from one channel and you want to put that data that you just read in another channel, there's like no way to synchronize that. And yeah.
Yeah, I mean, I'm trying to follow along exactly what you're describing. But do you mean like if they're buffered, the channels in Go?
No, not even, because even with an unbuffered channel where the read of the channel is synchronized with the write into the channel, but as soon as you take a value of the channel and then you want to put that value into another channel, then those two channels are really decoupled from each other. And you have like that at least always one thing in flight that you could potentially lose if your process crashes.
Yeah, but I mean, you know, it's arguably true. I mean, it's just copying memory around, right? Like the channel underneath, it's not network based, so it's really just moving memory from one location to another. So I mean, it's not that much different from just having copying it around to a local variable and then performing some operation on it and then calling another function. I feel like you could boil it down to the same fundamental things that are happening under the hood. But I think when you're talking about NSQ's implementation, perhaps like when you're considering clean closes, not unclean closes, right? Like if a process crashes, there's little you're going to be able to do for things that are in memory if the process crashes, right? That's why things write to disk or other stable storage. But NSQ does need to account for those things that are internally in flight if it's going to close the process cleanly, and that's like accounting for all those there's intermediate channels that it's using for go routine communication, and making sure all of them are flushed and empty as it sort of takes the scaffolding down. So like that was one of the areas where we had. It was both incredibly frustrating and challenging, like in terms of early versions of NSQ that were unstable and deadlocked on exit or things like that. Like it's really easy to create go routines, but it's not really easy to coordinate their exit, right? Because sometimes a go routine will be depending on a source channel for for progress. Like it's selecting on it, it's receiving on it, it's sending on it. Number one, you can't close that channel if some other go routine is going to send on it. Number two, if in order to make progress, a go routine needs to receive a message on a certain channel, that needs to happen in a coordinated manner as you're tearing these components down, right? So NSQ sort of starts from the bottom. It closes all client connections, which ensures that there will be no additional commands being given to that channel. Then it flushes the channel, then it closes the channel, then it flushes the topic, then it closes the topic. So it like builds this layer of starting from the bottom and decommissioning things, and then flushing as it goes up the stack.
It's interesting. I thought that you guys went like from top down, where you close like the main input source or whatever, and then you close that channel, and then the thing that is selecting on it or listening on it or receiving from it knows, okay, this is done, I can shut down, and then it closes its channel, and then the next thing in the queue knows to shut down. I thought that's how it worked.
Well, it gets triggered from the top level, but what happens is, like, if you call nsqd.exit, what's really happening is it's like iterating down that path I just described of like closing client connections and then closing channels and then topics. And then at the end, it might close its listeners first, actually. It might close HTTP listeners at the same time, basically, right before that it closes client connections. Client connections meaning like ones that are on the custom TCP protocol.
Right.
So that like walls off network communication, right? You can't access it via HTTP and you can't access it via TCP.
But if you close like the channel first, wouldn't that mean that you could potentially lose data in the topic? Or if you close the topic first, that you could lose data in the receiving code?
No, because that's what I mean. Like if no clients can send any commands,
right,
channel can drain input from the topic, which is where the flow of data is coming from, right? And then make sure it has its own persisted copy of it. They're all independent. And then the topic can close doing something similar.
Okay, right. So we just discussed like some very in-depth things. So maybe we should talk a little bit more like high level.
Sure.
So one funny thing is, as you know, I actually ended up transplanting the diskqueue code to another project called Carbon Relay NG because it felt like it fit right in.
Right.
Even though it was just part of the NSQD code, and it wasn't necessarily designed as a reusable library per se, even though it actually is really, really reusable. It was really easy to just take that out of its context and put it somewhere else. So I guess, how did you go about designing it? And I know that you guys put some thought into making it actually reusable without even promoting it as being reusable, but it kind of is.
Yeah, I mean, with the diskqueue stuff, we knew that, I mean, I think at one point we actually maybe had aspired for it to be pluggable, like this would be the file system based backend, but if you implement this interface, you could write to another persistent data store, So I think that was part of the motivation at the time. But it was really more our exploration of Go and its interfaces, So I think choosing good spots to take something as a parameter as an interface, or configure something as an interface, or structure it as an interface. It seemed like a logical spot to create some abstraction between the pieces of the code, the topics and the channels that needed to write to a backend, right? Not even persistent, and then where you persisted it seemed like a logical place to do something like that. So that gave us the opportunity to design a very specific interface for how we expected you to interact with that storage system. So in tests, for example, I think there's a couple tests that spin up maybe it's not tests, it's the ephemeral channels. They swap
There's
out.
like a dummy backend or something. Is that what you mean in tests? I've seen that somewhere.
There's a dummy backend that implements the same interface. It's like, get, put. I think there's a couple other methods, depth. And the dummy interface just stores things locally in memory, and we can swap that in and out. And I think it's used specifically for ephemeral channels, because ephemeral channels don't disk. And it was basically without changing any other code for message processing, we were able to implement this ephemeral aspect. Which is powerful in terms of what Go provides, right?
Yeah, but what you're describing now is basically you make the diskqueue and the different backends, like you make it so that you can easily swap them out and like hook a different backend or a different queue into nsqd. But the thing that I noticed is kind of the other way around, where diskqueue, it doesn't even have a notion of an NSQ message, meaning that you can take the diskqueue and put a diskqueue in another project, as opposed to swapping out different forms of backends within nsqd. You take one backend, the diskqueue, and you port it to another application, simply because it only cares about byte arrays or byte slices.
Yeah, exactly. Like we knew that we didn't want the diskqueue to define the NSQ's message format, right? Like they could be, they're completely orthogonal. So like how you might structure things on disk for proper diskqueue functionality is one thing, and it does that. It's like, size prefixed essentially, which is similar to the NSQ protocols, the data format, but not completely the same. There might be additional metadata you want to store on disk for other things, right? So like treating the inputs and the outputs of the backend, as it's called, like as something that was just bytes, then it just simplifies the way that the system interacts with that component. Like provides a lot of flexibility, obviously, for other use cases beyond NSQ.
Yeah. By the way, do you have like a hard limit at an hour, or could you potentially do more than an hour?
Let's see how it goes around 9:30. Because I might lose this room, and it's raining outside today in LA. I don't know why.
Okay. So yeah, I had some other questions, but I'm just going to move those to the end if we have time remaining, and we'll just talk a little bit about the wall now.
Yeah, we love talking about this, but it's still a figment of our collective imaginations.
Well, I guess the reason I'm so excited about this is because it makes So okay, when I think about NSQD and I compare it to Kafka, it's like you take away some of the Kafka properties that make it so much easier. Like you take away the strong consistency across nodes and the strict ordering and stuff, meaning you can get rid of Zookeeper and it's just so much easier.
Right.
And I had for a while been thinking actually like how cool would it be to implement something like Kafka in Go and like unrelated to the use cases that I've been using NSQ for. But now that I see you working on this write ahead log, in my mind, that like brings us a little bit closer to the Kafka style workflow of at least stricter ordering and like a more explicit, everything goes through the log. So I think it's interesting. And I mean, sure, clearly you have a reason for, working on it too. So there must be something better about it, right?
Yeah, I think it was like, I mean, we chose to implement the design of NSQ is like one of both in memory and disk-backed data storage, and we did that as like a reaction to our experience operating an entirely in memory queue that predated NSQ. Right, Simple Queue was its predecessor, and it was entirely in memory. And what would happen is like during operational issues or fires, whatever, like, that queue would just build up and it would just consume more and more gigabytes, tens of gigabytes of RAM on a given box, right? So the disk-backed queue, it was really just a response to saying like, okay, like we know we want it to be in memory for performance reasons, and that's the sort of semantics we're looking for. But what if we just added a overflow, right? So that, rather than consuming tens of gigabytes of memory, it'd be bounded to, average message size times number of queues, right? Roughly. So that's really all it was. Like, it was just a mechanism to give us more time to address whatever issues we were experiencing in production. Obviously, disk is also a finite resource, just like memory is, but it's typically less finite than memory, right? Like you tend to have maybe an order of magnitude more disk than you do RAM on a given box. So we knew that would give us a much larger runway to withstand, scenarios that were extended outages, right? And that's really it. That was sort of the design behind the overflow stuff. And then, naturally, that met our needs at Bitly, right? But, as a community formed around NSQ and more production deployments made it out there, like the number one thing I think I hear in terms of feedback is like, how do I provide stronger guarantees, right? That's been the common thread, right? NSQ is built around this philosophy of it's a simple set of primitives. It's primarily in memory. On a given node, assuming it is online, it has X guarantees, right? However, under these variety of edge cases, you can lose messages, right? So people naturally ask, well, how do I not lose messages?
Yeah.
I have critical business information that I need to guarantee at least once delivery, right? And persistence doesn't actually have anything to do with providing those guarantees. However, for a single node, forget clusters, right? Forget replication. Forget some of the other things you could do with in-memory data stores to ensure that the system continues to be able to provide that availability. Just switching to by default, persisting everything to disk gives you a stronger guarantee just within the context of that single node, right? So it eliminates a certain subset of edge cases where you would have traditionally lost messages. And I think what happened is like Kafka matured and proved that you can write to disk at a high rate and not sacrifice performance, right? So, disk subsystems have evolved. Most everything is on SSD now. They're not quite as slow and cumbersome and non-performant as they used to be. I mean, even things like EBS and Amazon, they're more reliable. They can guarantee IOPS. There's like the hardware has sort of matured as well. And I think, I mean, my belief is that we can change the way that NSQ stores data without necessarily changing the semantics that people have come to appreciate and choose, right, as a tool. So I don't know, that's sort of where the write-ahead log experimentation has come from. It's like, well, what if we just switch to always on disk back persistence with configurable flushing mechanisms to essentially, I mean, what it essentially becomes is you're using the the file system cache as a large in-memory buffer, right? That's essentially what you're doing.
Yeah.
And if you don't flush that often or at all, you're exposing yourself to obviously edge cases where data doesn't actually reach disk. But again, eliminating a lot of edge cases where messages would have traditionally been entirely in memory. And then, as you've alluded to, the side effect of that approach is that on a single node, there is more strict ordering. It's still not strict ordering. Like, it's not guaranteeing ordering of messages because, as I mentioned, the semantics are tending to provide the same semantics. Like, you can requeue a message, you can get that message again when its timeout expires. Like, all those things are not necessarily going away with the transition to a write-ahead log. So the ordering is going to be more strict, but still not guaranteed to be the order at which things were published in, or at least for retries.
So I don't know if you consider this the next logical question, but in my mind it is, would you or would the NSQ project be open to supporting some kind of mode where you don't have requeues or you don't have timeouts so that you can actually enforce strict ordering on a per NSQD basis?
Yeah, I think, the great thing is that what this change would also provide is like a platform to answer some of those questions, right? Like, is that something we want to do? Is it something we want to build? Is that NSQ version 2? Like, if you are persisting all the data that's coming into the system, it allows you to do things like stricter ordering in terms of the publish ordering, and also potentially replaying, right? Which is the other really, really powerful feature that Kafka provides.
Yeah.
So, those are questions that I don't have great answers to in terms of would we do it. I think I intend to explore what that implementation looks like for NSQ and see if it makes sense. Like, NSQ has succeeded as a project because of the design, and philosophy that we followed with it. So, I'm really conscious and concerned about, choosing a set of features and functionality that makes sense with what the original design goals were. And if they don't make sense, like, maybe that's a different thing,
Yeah.
Like, you have to respect the reason why it was successful in the first place. And I think you hit the nail on the head before, right? It's because it was simple. So if we can't implement these things we're talking about without providing a simple interface to them or a simple set of configuration knobs to administrate them, or in concert with all the other functionality that people rely on from NSQ, like, we're not going to do them, right? Like, that's the most important thing to me.
So how do you see the development process of the WAL project? And I mean, like, design process, but also is it like, it's pretty experimental from what I understand. Is it just like a little toy project of yours?
I mean, it's not really a toy. I mean, yes, it is a toy project in the sense that I have limited time, and like when it's like a nights and weekends thing. I've gotten a lot of design feedback from a variety of people about like how everything might all fit together. You've probably read through some of those docs. Like, that was a community contributed document that I helped moderate, but for the most part, it typically ends up that large features are developed by either myself or Jahaya, right? I mean, we've gotten a lot of great contributions over the years, but the bulk of development falls on us. So if it's ever going to happen, it's probably going to continue being that case. Like inspiring a community contributor is a difficult thing, right? Like I think it's actually a double-edged sword. I think NSQ works so well for people and is flexible enough to meet a variety of use cases that they don't end up needing to change very much. I think certainly people have requests, right? Feature requests, either minor or more significant. But for the most part, I think, I don't know, I believe it's a reflection of the fact that it works. Yeah, like it's hard to sort of put your finger on like how to motivate other people to contribute at that level,
Yeah, but I think an interesting distinction at this point is that WAL is a separate repository on GitHub, and that may seem like a superficial thing, but in my mind, it actually conveys like something more significant that maybe community could potentially build around just WAL. People who want to use WAL for different things and build their own daemons around it. That's also a direction that I'm interested in taking. I just need to spend more time looking at the WAL, and it's a little bit tricky to follow because I know that you explicitly say I will like force push and like don't pay attention to commit messages and all that, which makes it a little trickier to follow along. And I kind of wish that maybe it could be more open in that way to follow. But I guess
that's a fair critique, and I think I think I took your advice really this time around, and I started with the intention of the WAL package being something that was importable and open source directly, right? So like,
yeah.
I think the reason why I have that disclaimer there now is because it was such an early stage. Like I just needed to get something working, and I don't know if contributors would have been useful at that point, right? Like I have a very specific idea of what Alpha 1 should look like, and then we could form a, whether it's a mailing list or a document that we spec out the rest of the design and implementation process that we could follow along, divide and conquer in terms of contributions, and like stabilize master, clean up the commit log, and then actually move forward with pull requests, right? Like, I think we're probably close to the point where that's something that's like reasonable. Like more recently, I've been working on the NSQD side integration. Like I haven't touched the actual WAL code in a little bit of time because it mostly works in terms of what I originally wanted it to do. I'm sure there's probably tons of room for improvement, but like I answered some of the fundamental questions I had about how that could be implemented. So I take your feedback, and that's certainly something that we could work to stabilize if you're interested in contributing to that package specifically, because either way that ends up benefiting, I think, its relationship to NSQ and how it would use it, right? Like, yeah, I think that's a useful community package because I think there are hundreds of use cases where that would be something that's really valuable. And the way I see it is just an improved version of diskqueue, right?
Yeah. So you mentioned an interesting concept where you basically first create an initial version of WAL, and then you said, okay, I haven't touched it for a while. Now I'm going to work on the NSQD and how it calls the WAL. And this reminds me of something I read. Do you know the book Coders at Work by any chance?
Yeah, I have that one. I haven't read all of it, but I know of it for sure.
Yeah, so it's a book that I really enjoyed reading through, and I remember it came up at least once, maybe several times, where people were talking about API design, and this notion of I'm first going to design my caller and how I want to use an API before I even implement the API, like the implementation behind the API. And I thought that was really interesting, and I haven't personally really done it much like that. But some people apparently think it's really good to first design, okay, this is how I want to use the API. Whereas I am more of the idea, okay, like there's just so many constraints within the implementation, and that kind of dictates a little bit how it's going to be called. I don't know if you have thoughts on that.
I guess they would argue that if that's the case, then the abstraction is leaky in the first place, right? So I think, in Go specifically, like if you design with an interface first, that's effectively what you're talking about, right? Like if you design, you actually write out, like code the interface. You can mock out an implementation for that interface, begin updating client code that would call it, and then backfill it with an actual concrete implementation that does the thing you do, right? So I think that would be the way I've been following it, or I don't know if I did exactly that in this case, but like how I would do it for if I was going to use Go as the language of choice for that system. Like designing with interfaces first, I think would be the way to do that, or one way to do that at least. Obviously, there are other APIs, that don't end up using interfaces.
Yeah, I should probably practice that style a little bit more, because as you say, like, or as I said first, like I have the problem often that my implementation of the API dictates a little bit how you call it, and then you said, okay, well, that's because you have a leaky abstraction. Maybe that's true. I should look into that more.
Yeah, I think like maybe at an even higher level, what you're really describing is like thinking about the user first, right? Like there is always a user, even if you're not building an end user product like traditionally, like a consumer website or a mobile app or something. Like even as as one of the people who built NSQ, like there is a set of users, right? Whether it's the Go NSQ package, whether it's the system itself. And I think one thing we did reasonably well was being considerate of how they would use the system, right? So like you can see that in the fact that the way it focuses heavily on operations and configurability, right? And like dynamic service discovery and stuff like that. And that's stuff that like, it's not the most elegant system. Like some of its approaches are naive, but they work very well in production. And they predated a lot of the other tooling that has come to be in the Go ecosystem, right?
Do you mean your approach with NSLOOKUPD?
Right. That
Yeah.
I was also going to say like the fact that it came bundled with a bunch of other common consumer utilities that you could use right out of the box, right? Like you're going to need to archive a stream to files. There's NSQ to file. You're going to need to take a stream and make HTTP requests. You can use NSQ to HTTP. You're going to need to copy one stream to another NSQD. You have NSQ to NSQ. We built a suite of utilities and helper applications that allowed you to get started right out of the box. There's an admin UI, right? You have to be considerate of your users, right? So designing with an interface first is you going through the process of thinking about how that user is going to interact with your system, even if it's just a package that they're going to compile into their Go app. And even if it's just you when you go to use that package, right? Like you could be your own user. But rather than focusing on the implementation, focusing on their experience as a user.
So one other major difference that I noticed between diskqueue and the wall, and maybe I'm misunderstanding it, but from what I understand, there's like some kind of index that has pointers to every single message within the wall.
Right.
I feel like that's kind of a big difference, and I guess it's needed to support seeking, or?
Yes, exactly. You need to be able to like know how to find the message index you're looking for. And the map provides a mechanism for you to, it's not exact. The map doesn't provide like one-to-one. I'm looking for, ID number 1, 2, 3, 4. It's not going to be able to answer the question. That's at, file 7, position 85, right? What it will be able to do is get you into the right file and then get you into the right approximate location. So what happens is it looks up in the map for the file that the diskqueue file, the wall file, and then you get a file offset pointer to something that's like maybe within 5,000 messages of 500 messages of the index you're actually looking for. So you sort of start and then you iterate forward until you actually find the message ID you're looking for. So it does a little bit of scanning as well as like seeking.
So one thing I didn't get is, why is it inexact? Is it not the same? Like, is it not a set of pointers where you have message ID to a specific seek location?
It's because it doesn't necessarily make sense to store an index for every message. That's basically right. Like, so the index becomes much smaller
Right.
because it's only indexing 1/500th of the message volume, right?
So
Whatever
it's just
whatever that gap is, that's going to
yeah.
be your efficiency saved or whatever, you know.
So you would just index every 500th
Yeah.
package message. All right. Well, I think it's time to wrap it up.
Yeah, thanks, Dieter. This was great, man. And I mean, if you have more questions, I could probably go for like another 10 minutes, or until somebody kicks me out. But that's probably about it.
Well, the other stuff I have is like, oh yeah, actually I do. I have one more thing. The new internal thing well, I think I thought it was new in 1.5, the internal packages, or maybe it's like strongly enforced that you can't reuse packages that are in an internal subdirectory. And when I found that out, I didn't like it, because you may have read in my last blog post, and also, diskqueue is an example. I like to read code of other projects, find stuff that I really like, and then just reuse it. And then sometimes I hit this code that is in an internal directory, and I can't just reuse it. I actually have to copy it somewhere else, and then I can use it. And it's so weird.
Yeah, I think the Go team, they're very careful when it comes to the APIs that they expose, and I appreciate that fact about the way that they design the language and its tooling. So, we feel the same way about the APIs that we expose as the builders of